Currently, veterinarians typically collect CSF from South American camelids and other farm animals using two main approaches, either at the atlanto-occipital space, which is located at the back of the head, or at the lumbosacral space, situated in the lower back. However, collecting CSF at the atlanto-occipital space carries a greater degree of risk because the needle needs to be placed very close to the brainstem, often requiring the animal to be under general anesthesia. On the other hand, obtaining CSF can sometimes be challenging regardless of the chosen site. Over the past 3 decades, advancements in veterinary medicine have led to the development of ultrasonographic techniques to assist in successful CSF collection in various animal species, including companion animals, cattle, small ruminants, and horses. Notably, a new ultrasound-guided technique has been described for horses, allowing CSF to be collected from the atlantoaxial space, which is located in the neck between the first and second vertebrae while the animals are standing and sedated. This method involves using ultrasound to visualize the subarachnoid space, where CSF is found, between these two vertebrae, and then collecting the sample using a lateral approach. While this technique has shown promise in horses, it had not yet been scientifically evaluated in South American camelids. Therefore, the researchers in this study set out with 2 main objectives. Firstly, they aimed to describe the ultrasound-guided atlantoaxial CSF collection technique in sedated South American camelids positioned in sternal recumbency, meaning lying on their chest. Secondly, they wanted to compare the technical difficulty of this new atlantoaxial technique with the more traditional lumbosacral technique, as well as to compare the characteristics of the CSF samples obtained using both methods. In conclusion, this study suggests that the ultrasound-guided atlantoaxial CSF Centesis technique does not necessarily yield samples with less blood contamination compared to the standard lumbosacral technique in South American camelids. However, the 2 techniques were found to be comparable in terms of technical difficulty. The researchers proposed that the atlantoaxial technique could serve as a viable alternative for CSF collection in South American camelids, with the choice between techniques being guided by individual clinical circumstances, the suspected location of the neurological problem, the operator's skill, the animal's cooperation and physical characteristics, and the availability of the required equipment. Further research is warranted to assess the utility and safety of ultrasound-guided atlantoaxial CSF Centesis in animals presenting with neurological disease.